start next example. The man use the hand track to move the material out of the state. If the track and its content have mass of 50 kilogram, with center of gravity at G, determine the normal reaction on both wells and the magnitude and the direction of the minimal force required at the grip B needed to lift the load. Okay, so we have the maybe one and two objects, and we also can see this like combined together in one object. And we have the one support at here, and we put a one force at here. So we can draw the free body diagram first. the theta angle like this, like this. Okay, so we just use this angle is the theta. So the angle theta here. Then we can get this dimension moment A equals to 0, and we can get the Px answer. Px answer is equal to So we also can do the summation fx, use the px and the na. So the na is equal to px, na is equal to px, and the angle of the p. Okay, so these two forces we can component together in one P. And how to check the angle? Check the angle of the direction of the minima force are required. Okay, so this theta maybe will change because the P, if you want to get the minimum P, we just change this angle. Okay, so this angle we use the okay, so minimum P. This simple answer is equal to 616 Newton, and Na is equal to 442 Newton, and the C is given. The member is supported by a square rod which fits a low stick through the small square hole of the attached collar at point A and by a roller at point B. Determine the components of a reaction at this support when the member is subjected to the loading, show like this. So we have one object. This object, the shape is square, and we have two supports. One is at the point A, we call the collar, and the one is the roller at the point B. Okay, and we put the force, the three forces at the point C. So we can draw the free body diagram first. And point A is the polar, but the hole is the smooth square hole. So at the point A have the maybe three unknown about the moment. Okay, one is this direction, one is this direction. We also have the three reaction force this direction. So the force Fx, Fz, and Fy. And we also have the roller support at point B. So we have a perpendicular reaction MD, and we have a strong force here. Alright. Okay, so we have so many force in this free body diagram, but we also solve determine the moment. Okay, we only determine the moment. So we can set the moment point at the point A. If you set the point A, you don't care the AY, AZ, AX. Okay, if you set the moment point at this point, I think it's wrong because the support is here, and the support is here. So we can try to calculate this part, then we can use the vertical analysis. So the FA, non-vertical vector analysis. We can use the vector analysis. So FA is AX I AYJ, and the F is equal to 300 I plus 500 J minus 4 8 into minus the MA CK. Okay, and when we use these three force, then calculate the moment to this point A. We use the position vector from this point to this point. So we have a position vector R AC here. And we also have the MB, need to calculate the moment. So from this to this, we have the R, A, B. Position vector R, A, B is equal to 2I, and RAC is equal to 3I minus 2K. Okay, so we have these 1, 2, 3, 4, 5, 4 force Cartesian vector form and 2 position vector. Okay, so we can do the summation F equals to 0 and the summation moment equals to 0. So we do the summation F equals to 0, Fa plus the F plus the MB equals to 0. Equals to 0. Okay, so the I part also equal to 0 because summation Fx equal to 0, summation Fy equal to 0, summation Fd equal to 0. So we can easy to calculate the Ax equal to 300 Newton and the Ay equal to 500 Newton, and the MB is equal to 400 Newton. Okay, so we have these 3 force answer over here, and then we can do the summation. Moment A is equal to 0. Summation moment A equal to 0. Moment A plus position vector AB cross the MB plus the position vector AC plus the F is equal to 0. So MAXI plus MAYJ minus MAZK plus, okay, we can use the determination to calculate the moment. Use the Cartesian vector, position vector cross the force vector. some massage, then we can get I part, take J part, K part. Then okay, so the I part like this. And this is the I part, and this is the J part. And this is the K part. And the I part, J part, K part also like summation mx, my, mz is equal to 0. So we can very easy to get the answer, the moment answer. X is equal to 1 kN/m. A y is equal to 200 Newton meter, and A z is equal to 1.5 kilonewton meter. In this example, determine the reactions acting on the smooth uniform bar, which has the mass of 20 kilogram. So we have the one support and two support here, and this part maybe have the two because the ground is one support and this point A is other support. So we can draw the free body diagram first. This is the object, and we have the action at the point B. This direction for the point B. And then we also have the two support, one in here and one in here. So we have two reaction force, Ay and Ax. In this object, we have the mass, so we have the weight, force here, force here, and then the direction angle is equal to 30 degrees. And about the direction angle, okay. See, 30 degrees and 60 degrees. Okay, so now we can set the moment point at the point A first. So the summation in A equals to 0. use this force and this force to calculate the moment of the point A. So MB cosine T3 times the moment down minus 20 the weight force times the moment arm is equal to 0. So we can get the MB is equal to 98.1 Newton. So when we have the MB force, then we can very easy to calculate the X and the AY because we use the summation Fx equal to 0 and the summation Fy equal to 0. Okay, so summation Fx equal to 0 is Ax minus value sine 53 is equal to 0. So the Ax is equal to 85 Newton. To the summation Fy equal to 0. The Ay plus the weight of force y direction sine 60. Then minus the force and equal to 0. So the Ay equal to 147 Newton. Okay. In this example, the cause the uniform create having a mass of 85 kilogram. Determine the vertical reactions on the three cluster at the point A, B, C. The cluster at point B is not shown. Okay. So look at the mass of the cluster. So we have three supports. Every support is like the water, so only one perpendicular reaction, and we can do the summations, because the summation Fx is equal to 0, summation Fy equals to 0, and we don't have these two direction force. So we just focus on the summation F C is equal to 0. Then the MB, NA, NC force combined together